Cyberpunk just got a huge update. It now supports DLSS 3. Let's talk about frame time latency, FPS improvements, and put it up against the 4070 Ti. Let's do it. Okay, here's what we're going to do. We're going to start Cyberpunk and run it without any DLSS enabled. We're going to take a look at the FPS numbers and the frame time latency. Then we're going to crank up DLSS upscaling, then DLSS 3.0, and then DLSS 3.0 plus upscaling, and we're going to compare all the FPS numbers, frame time latency stuff. And in the end, we're going to take a look at the image quality of all those settings compared to each other. Let's do it.
Okay, let me quickly run you through the specs of the test system. All tests were conducted at 1440p, no VSync enabled. In between tests, the PC had time to cool down again, and I restarted the game whenever I changed graphics settings. I had some bad experiences in the past in Cyberpunk when not restarting on graphical changes, so I wanted to be better safe than sorry. The test PC features a Ryzen 9 5900X CPU, an NVIDIA RTX 4070 Ti, and 64GB of RAM. No overclocking was applied, all components ran at stock settings. The game was started off an NVMe drive, although we are not looking at loading times today. So, plenty of power, I guess, but let's take a look at the test results. For a fair testing procedure, all tests show the same scene, just with different graphics settings with regard to DLSS and frame generation. For each test, the Ultra Raytracing Preset was enabled and then modified with regard to the DLSS settings. The current settings will be displayed at the bottom for each test. Afterwards, we will take a look at the graphics quality for the different settings in a side-by-side pixel peeping comparison. At 1440p, with the Ultra Raytracing Preset enabled and no help from DLSS or DLSS frame generation, we end up with 99% of our FPS above 42. You want the FPS number to be as high as possible, and it shows how many frames per second are output to your display. We do not hit the magic super smooth 60 FPS here, but for a single player title you would be fine with a slightly above 40 FPS, as I found this value to be very constant in this scene. The average PC latency is a fine value of 45 milliseconds. This is totally okay, especially considering this high graphics preset. NVIDIA Reflex low latency is enabled by default for all the tests in Cyberpunk. This really helps with the latency, and there's no reason to turn it off in this title. This average PC latency number is not to be mistaken with the frame times you often see in other tests. This PC latency value shows how long it takes on average after an input to actually show a change on the screen. For example, click the mouse and see the gunfire on the screen. This is really important for competitive games and shooters, and in general, you want this number to be as low as possible. Now that we have set a baseline, it is time to turn on DLSS. Wow, now look at this. Just by enabling DLSS 2 and thereby taking some load off the GPU, we end up with a 99% above 66 FPS, and our PC latency dropped to an amazing 16 milliseconds. This is a really great value. DLSS 2 at the quality preset means the GPU renders the scene at a just slightly lower resolution. In this case, it renders at full HD, and then uses the NVIDIA Tensor Cores or AI accelerators to upscale the image to 1440p while retaining fine details and adding a slight sharpening effect to hide the upscale process. I am very curious if we can spot the difference in image quality in the side-by-side comparison later in the video. But first, let's turn off DLSS quality and just activate the AI frame generation. Oi, now look at this. We get even more FPS with 99% above 72 FPS, and the CPU load dropped, cause all the additional frames are purely generated in the GPU without any additional help from the CPU. All data like motion vectors of 3D objects and pixels are used to guess, by the AI what kind of frame comes next based on the previous frames that were already rendered. This can lead to artifacts and yields best results if the base frame rate is already high. Honestly, the result looks great to me. Unfortunately, the PC latency went up from 16 to 26 milliseconds. But perhaps we can fix this? Let us unleash the full potential of the 4070 Ti and enable DLSS quality again, but this time with frame generation enabled. Alright, this is it, the holy grail of settings. DLSS quality enabled plus AI frame generation gives us a whopping 105 FPS and a latency of just 17 milliseconds. Remember, the best value we had before was 16 milliseconds, so we are back to that within margin of error, but we went from the 99% above 42 FPS at the beginning of our journey to a whopping 105 FPS. That is a 250% improvement. What the hell? Quo modo vales, Nvidia. But there might still be one big problem. The image quality. Does it suffer? Let's find out now in a side-by-side comparison, shall we? Alright, here we go. Okay, this is the overview. We will zoom in a moment. Top left, you've got DLSS off and no frame generation. Top right, you've got DLSS on the quality preset, no frame generation. Bottom left, DLSS off, but AI frame generation on. And bottom right, all features enabled. Quality DLSS and AI frame generation. Okay, let's zoom in. This is the upper right corner of the screen, which includes the GUI elements, like the text overlay and the map. I can't spot any differences or artifacting, but look at the horizontal green light stripes. Let's zoom in on them even further. Interesting, the green horizontal light seems to pulsate or change its intensity whenever DLSS is enabled. Also, the definition of the fine texture on the green light becomes more a green blurry shining. Both cases with DLSS disabled don't exhibit this behavior. Without zooming in and the side-by-side comparison, I honestly might have never noticed this. Okay, let's move on to the next artifacting I found, a slightly more interesting one this time. While in our first example, DLSS messed up the texture on the green lights, this time it actually enhances the image. Take a look at the first letter of the E of L from the neon name sign of the bar. Both examples with DLSS off exhibit a merging of the horizontal lines of the first E from time to time, not showing any space between the horizontal yellow lines of the E anymore. On the other hand, with DLSS enabled and thereby rendering at a lower resolution but upscaling with AI, the definition of the E and the spacing in the horizontal lines is clear and much better. It might sound crazy, but the AI is trained to enhance and preserve small details while upscaling. This behavior of DLSS has been reported by others, example given on details of fences in the distance, etc. These fine details apparently become more clearly visible by the AI upscaling process than rendering at the native resolution. Kind of insane, and a nice example of DLSS surpassing the quality of the rendering at the native resolution. Okay, here is a last challenge. It is for you to guess which one of those 4 videos is which. Well, I mean like using which technologies. Yeah. So, take a close look at the moving arrows, the details on the table, the metal fence or whatever that is behind the table, and yes, can you spot differences? Where? And what do you think, which one is which? Okay, let me tell you something. I lied. I did not shuffle around the 4 videos. Let me put up the labels for you on the screen again. Honestly, did you spot any major differences in the image quality here? I can't. Amazing how far technology has come. Okay, time for my final verdict. Yes, I know that you can spot completely AI-generated frames from time to time in fast-paced action sequences when, and mainly when, completely slowing down the footage and looking carefully. And yes, you can spot the artifacts then, like half-rendered things, kind of ghosting in the frame. But the more real frames you have, the artificial ones just get lost in the flow of total frames and fluid movement when played back at 100% speed, and gaming itself happens at normal speed, right? I also tested DLSS 3 frame generation in The Witcher 3, and I could not spot any problems in any of the many fast-paced fights with regard to image quality. So my opinion on DLSS 2 upscaling and DLSS 3 frame generation? These two technologies combined are just amazing. DLSS upscaling brings down the PC latency, which alone already is super compelling, cause more FPS and lower PC latency is a great combo. While the frame generation feature alone introduces additional latency, activating the DLSS upscaling here too perfectly lowers the latency to values that match those with DLSS upscaling activated alone, but this time with even more FPS. For me, activating all the DLSS features is a no-brainer. Going from 42 FPS in Cyberpunk with Ultra Raytracing to over 100 FPS with even lower latency is just so awesome, and the game feels so super smooth. Honestly, I would not want to miss out on those features once I experienced them. What about you? What do you think? Just gimmicks or a serious enhancement? Leave your opinion in the comments down below. Thanks. Okay, that's it for today, lads. Don't forget to like, follow and subscribe. And see you in the next one. Stay safe. Alpha, over and out.